Welcome back to session 4 of lipids, and this is part 1.2. In this section we're going to actually look at unsaturated fatty acids. The next slide is a monounsaturated fatty acid. And why do we know that's a monounsaturated fatty acid? We know that because there's one double bond in the carbon chain. This is in fact oleic acid, which is an 18 carbon monounsaturated fatty acid. And another way of describing this is omega-9. And it's omega-9 because if you look at the methyl end, which is depicted in green, and you were to count 9 carbons in from the methyl end, the first double bond occurs at the 9th carbon, which is where it gets the name omega-9. The carboxyl end, depicted in pink, is what actually attaches to the glycerol backbone. And if there were 3 of those, that would in fact be a triglyceride. Monounsaturated fatty acids therefore have one double covalent bond. They are less stable than saturated fats, and they're less stable because of the double bond. And because of the double bond in the cis configuration, atmospheric oxygen can actually break that double bond, and again it can be easily oxidized. Food sources of monounsaturated fatty acids include avocado, pecan, cashew, macadamia, olive oil being extremely high, and also peanut oil. They are typically liquid at room temperature and used for energy storage. So the functions: structural integrity of cell membranes, improve lipoprotein profiles, so thereby increasing HDLs and lowering of LDL cholesterol, reducing blood clotting, reduces cellular oxidative damage, reduces atheroma and plaque formation, and reduces the risk of gallstone formation. Therapeutic uses of your monounsaturated fats. There's been quite a lot of research on the Mediterranean diet, and some of the benefits of Mediterranean diet unquestionably are attributed to the high levels of monounsaturated fats, omega-9 or oleic acid, and so cardiovascular disease, including hyperlipidemia, which is elevated lipids in the blood, and also reduces the risk of stroke. So substitution of foods that are rich in saturated fats with foods high in oleic acid has favourable outcomes on blood lipids and clotting factors, so again reducing the risk of stroke and reducing the risk of cardiovascular disease. Also providing some benefit in weight loss. If you substitute saturated fats with monounsaturated fats, you can induce a small but significant loss in body weight and fat mass without significant change in energy intake. Next we're going to look at polyunsaturated fats, and polyunsaturated fats have more than one double bond, unstable and liquid at room temperature, and the reason they're more unstable than a monounsaturated fatty acid and obviously a saturated fatty acid is because they have multiple double bonds, and as previous, those double bonds represent an opportunity because of the cis configuration of hydrogen atoms for the oxygen to actually break that bond. Therefore they're sensitive to light, heat and oxygen. Most vegetable oils contain polyunsaturates, and omega-3 and omega-6 are essential fatty acids are included in this class. So the functions of polyunsaturated fatty acids required for cell membrane fluidity and integrity. They have more consistent at raising HDL cholesterol than polyunsaturated fatty acids, and that is particularly your essential fatty acids, and particularly omega-3 has a positive impact on HDL cholesterol. And why that's advantageous is because HDLs, lipoproteins, pick up excess cholesterol from cells, peripheral tissues, and bring them back to the liver where they can be metabolized and eliminated in bile, for instance. Linoleic acid, which is omega-6, and alpha-linolenic acid are considered essential and cannot be synthesized by the body, and so these must be consumed in the diet. There's a warning here, and smoking fats, so cooking fats at very high temperatures, increases oxidation of those particular fats, and is obviously not a great thing to do for health. So therapeutic uses, these will be discussed more in the next session. Just a point that's made here is despite the positive health benefits of polyunsaturated fatty acids, especially those related to cardiovascular disease, there is adverse health effects, or considered to be adverse health effects, if fatty acids are consumed in very high amounts due to their vulnerability and their vulnerability to oxidation. So essentially what that means, at therapeutic dosages, there's no risk of that, and typically, or the upper limit of therapeutic dosage for the long-chain derivatives for EPA and DHA is in fact 3,000 milligrams per day, and there's no risk at that particular dose. So what we're talking about is dosages far in excess of that, which will be discussed in further classes. This next slide gives you a visual and colour visual representation of the different types of fatty acids contained in food. And again, this points to the fact that it's an oversimplification to actually categorise foods according to one particular fatty acid. But if you want to look at the green bars and the yellow bars here, so the omega-6 is the green and omega-3 is the yellow bar, flaxseed oil is our richest plant-based source of omega-3. And then you've obviously got other sources here like walnut oil, soybean oil and canola oil, all viable sources of omega-3. And that's omega-3 as in alpha-linolenic acid. If we look at omega-6, omega-6 is much more abundant than omega-3 in the food supply. And again, omega-6 is quite abundant in all nut and seed oils, as very clearly indicated there, whereas monounsaturates such as olive oil is a clear indication of the high levels of monounsaturates, for instance. On this next slide, we're looking at food sources of essential fatty acids. So on the left-hand side we have omega-6, and on the right-hand side we have omega-3. So we're looking at linoleic acid. You've got food sources listed under there, so very high in your seed oils, for instance, also in soybean oil. Gamma-linolenic acid is a linoleic acid derivative, and we'll look at that on the next slides. Even primrose oil is a good source of gamma-linolenic acid. Looking at omega-3 on the right-hand side of this table, you'll see that linseeds is listed as a very high source of omega-3, of alpha-linolenic acid, and it is. Again, walnut oil, chia seeds, seaweeds, green leafy vegetables, legumes, watercress are all really good sources of alpha-linolenic acid. If we look at the long-chain derivatives, we've got eicosapentaenoic acid here and docosahexaenoic acid here. You'll notice that fish and seafood, particularly oily fish and seafood, are very good sources of these long-chain derivatives. This is a simplified representation of the essential fatty acid family. So on the left-hand side we've got omega-6, and on the right-hand side we've got omega-3. So omega-6, looking at some of the longer chain derivatives of linoleic acid, you can see you've got gamma-linolenic acid, dihomo-gamma-linolenic acid, and arachidonic acid. Evening primrose oil is a very good source of GLA, whereas breast milk is very high in DGLA. On the other side, you've got omega-3 family, so alpha-linolenic acid, which is 18-carbon omega-3, and some of the longer chain derivatives, so eicosapentaenoic acid and docosahexaenoic acid. On this next slide, we're looking at essential fatty acid pathways, and although this probably looks somewhat complex to you, I'm going to try and simplify the explanation. So there's a couple of things that I want you to actually note when looking at these pathways. So in the middle of the slide you'll see red, and I want you to basically observe some of the enzymes that are listed there. You may recall that I talked about desaturase enzymes and elongase enzymes previously. So up the top you've got D6D, and that stands for delta 6 desaturase. Then you've got elongase, And then underneath that you've got D5D, which is delta 5 desaturase. And recall when I was talking about the cofactor nutrients, I mentioned B6, zinc, magnesium and vitamin C. Those nutrients support those enzymes that facilitate the conversion of your essential fatty acids of omega-6 and omega-3, so those 18 carbon fatty acids, into the longer chain derivatives. So the desaturase enzymes add double bonds and the elongase enzymes add carbons. You don't need to worry too much about that at this time, because this will be covered next semester in great detail in nutritional biochemistry, but I just wanted to introduce you to these pathways now so you gain somewhat of an understanding of the implication of these in health. The next thing I want you to actually look at are the boxes that come out from the particular pathways. So essential fatty acids are really important, and they're really important not just because of their prevalence within the central nervous system, but because of their anti-inflammatory effect. What they produce are these local eicosanoids, and these local eicosanoids have an anti-inflammatory or somewhat of a pro-inflammatory effect. So if we're looking at omega-6 pathway, and we start at the top, and you can see 18 to omega-6, so that's doing 18 carbon, 2 double bonds, and the first double bond appearing on the 6th carbon. And then you follow that down to GLA, and then GLA basically becomes DGLA, and DGLA produces anti-inflammatory eicosanoids. Anti-inflammatory eicosanoids reduce the risk of asthma, have a positive effect on platelets, reduce the risk of cardiovascular disease. On the other hand, if you go back to that pathway and you go back to DGLA and you follow that down to the next, which is AA, and AA stands for arachidonic acid, that arachidonic acid produces pro-inflammatory and also anti-inflammatory eicosanoids. And if you recall, going back onto the previous slide, animal foods also provide a lot of arachidonic acid. So what does that mean? Well, it means if we actually have a diet that's very high in animal foods and a lack of omega-3, it can have a pro-inflammatory effect. And that's because they're both competing, both pathways are competing for that delta 5 desaturase. Again, don't worry about that too much now, but I just want you to have some basic concepts of this particular pathway. Now let's go to the omega-3 side of things. So again, up the top you've got omega-3, which is an 18 carbon, 3 double bonds, and the first double bond occurring on the 3rd carbon from the methyl end. So that's alpha-linolenic acid. So you've got the omega-3 pathway here, and it goes down through a variety of fatty acids. And so you've got saturninoic acid, so let's go down to ETA. EPA is eicosapentaenoic acid. And EPA produces these less or anti-inflammatory eicosanoids. Then EPA converts down to DPA that we've looked at previously, and DPA produces DHA, and DHA produces these anti-inflammatory docosanoids, which are a relatively new finding, but just another point is that DHA is very, very important for very highly concentrated within the central nervous system, and very important for maintenance of myelin, myelin sheath, and therefore importance for the maintenance of our central nervous system. So just thinking about this chart again, omega-6 pathway down to GLA produces anti-inflammatory eicosanoids, and they're typically series 1 prostaglandins. If there's excess conversion to arachidonic acid and also a high animal diet, that's going to produce more pro-inflammatory eicosanoids, and that's series 2 prostaglandins. And if we look at omega-3, we go down that pathway to EPA, we're going to produce series 3 prostaglandins, and they are anti-inflammatory prostaglandins predominantly. So just to recap, Linoleic acid, omega-6, can make arachidonic acid, which is a conditionally essential fatty acid, and it certainly is important, and we need both inflammatory and anti-inflammatory reactions. But if the diet is too high in animal foods and there's a lack of omega-3, we will produce or have a pro-inflammatory effect. Alpha-linoleic acid, omega-3, again, is an essential fatty acid, and again it produces this EPA, which produces series 3 prostaglandins, which is anti-inflammatory, and DHA, very important for the central nervous system, for ocular health, brain and heart health. Dietary sources of omega-6. Linoleic acid, so safflower, sunflower, hemp, soybean, sesame and walnut. Gamma-linolenic acid, so borage oil, blackcurrant oil, evening primrose oil. DGLA, mother's milk, and arachidonic acid in animal foods. Omega-6 deficiency is rare because omega-6 is abundant in plant, seed and nut oils. So we rarely see omega-6 deficiency. Some people may have problems with conversion of omega-6 through to the longer chain derivatives, let's say through to DGLA, and that can be because there may be a deficiency of those cofactor nutrients that I previously mentioned, B6, zinc, magnesium, vitamin C. This is a diagram of linoleic acid, omega-6, and again, if you recall what we were looking at 2 slides previous, an 18 carbon polyunsaturated fatty acid. The reason it is polyunsaturated is because it has more than one double bond, and in fact this one has 2. The reason it's called omega-6 is because the first double bond occurs 6 carbons from the methyl end, and remembering that's the green section, so you count 6 carbons in and there's your first double bond. After the first double bond, every additional carbon bond always happens at 2 carbon intervals, so you can see the second double bond is 2 carbons from the first. Arachidonic acid is a polyunsaturated fatty acid, and again it's found in animal muscle meats, but it can also be made from DGLA. And again, arachidonic acid is there, as I said previously, there's really no deficiency is prevalent with the omega-6 deficiency. Arachidonic acid also being widely spread in animal foods, we don't really see a deficiency of arachidonic acid. Looking at the functions of arachidonic acid, required for contraction of smooth muscle fibres, an optional component of cell membranes. It's also involved in brain function, so a constituent of the central nervous system. It's a constituent of sperm. And the next point basically talks about some of its inflammatory actions, which is this pro-thrombotic effect, meaning it's pro-blood clots. And it's also involved in testosterone production. So arachidonic acid is an essential fatty acid derivative and conditionally required, as previously stated. It has essential functions as listed here, but just recalling what was said previously, too much arachidonic acid has a pro-inflammatory effect. Omega-3 sources: rice bran, flaxseed, soybean oil, dandelion, walnuts, pumpkin seeds. Docosahexaenoic acid, so your longer chain derivative. Some food sources here, so brown and red algae. And essentially the rest we're looking at oily fish, so mackerel, halibut, salmon and so forth. Eicosapentaenoic acid, same foods. Again, so your brown and red algae, and again your oily fish, and they're listed there as well. Eicosapentaenoic acid, green lip mussels for instance, and stearidonic acid, endogenous production, and also contained in blackcurrant seed oil. In this table, the amounts of omega-3 fatty acids in fish and the amount of fish consumption required to provide 1 gram of omega-3 per day. And if we're just looking at the chart, it's actually ranked in the highest quantity of omega-3, and you can actually see up the top there, so amount of fish consumption required to provide 1 gram of omega-3. You can see ling is at the top of the chain. Then you've got bluefin tuna, deep sea bream, coral trout, barramundi, skate, northern whiting, John Dory, and so forth. Now this table is actually taken from an American paper, and as you would appreciate, all of those fish aren't widely available here. From an Australian point of view, one of the primary sources of omega-3 in terms of fish are more clearly indicated on this slide. So herring, mackerel, halibut, salmon, sardines, anchovies, trevally and mullet. The good thing about those fish as well, as opposed to your swordfish and your tuna, which still contain high amounts of omega-3, they're large predatory fish, and we know that they do contain environmental mercury, and we definitely want to limit those fish, and we particularly want to limit those fish with children and women that are pregnant. So next I'd like you to undertake this activity, and after you've undertaken this activity, I would like you to resume this session, and we're going to do part 1.3.